Hey guys, these are the 5.2 notes. These focus on properties of exponents and radicals. Um, and the first part is a couple properties that you should be used to by using them on integer exponents, but they also work with rational exponents. So what I'll do is I'll go through them and give you like an example. Like a numeric example. So it says if you have a to the m times a to the n, right? What you do is just add their exponents. So we're like 4 to the 2/3 times 4 to the negative 1/3, right? Add the two exponents. So you add 2/3 and negative 1/3, you get 4 to the 1/3. Okay. Remember, when you're adding, you need common denominators. Next one is quotient, right? So when we're dividing exponents, right, we subtract the exponents. Okay, so example, if we have 3 to the 4th over 3 squared, right, this is equal to 3 to the 4 minus 2, or 3 squared. If you want to reduce that, you could write 9. The product, okay, that means you multiply the exponents, right? So 7 to the 3rd raised to the 2/3, right? We multiply them, okay? So you get 7 to the 6 over 3, which is 7 squared, or 49. Next one, if we have a product, a power of a product, right? So we're raising a multiplication problem to a power, right? We distribute that power to each of them. So for example, say we have like 16x, and it's raised to the 1/2, right? Distribute that 1/2 to the 16 and to the x, right? And then we could reduce that if you, because we take the square root of 16 is 4, and then we leave x to the 1/2. And then the last one is a negative exponent. When you have a negative exponent, what you do is you put this exponent under 1. Okay, so if we have 5 to the negative 1/2, right, what we're going to do is we're going to put 1 over 5 to the positive 1/2. And those are our properties. So we're going to use those to solve different problems. First problem would be just rewriting the expressions using the properties. Okay, so we have right here product of powers. So we know we have to add that the exponents. So right, we have 81 to the 5/6, and then we have to add negative 1/3 to it, right, to get our new exponent. Well, if you need help, right, it's the same as negative 2/6, because we need to have common denominators to add them, right? So it becomes 81 to the 5/6 plus negative 2/6, which reduces to 81 to the 1/2. Right, because it becomes 3/6, which is the same as 1/2. And if you want to fully reduce that, right, that's the square root. Right, we know this is the same as saying square root of 81, right, which is 9. Next one, right, we have a quotient property, right? So using the quotient property, what we're going to do is we're going to take our x to the first power from the numerator, right? And because it's quotient, right, we do x to the first minus x to the 1/2, right? Because that's the denominator. And then our y in our numerator stays y to the third. And then there's no y in the denominator to subtract from it. So we just leave it like that, and that's raised to the 2/3 power. Right, so I took just the x's, right? So that's x to the first minus x to the 1/2, right? So that's where this piece comes from, okay? So we don't need that anymore. Now, right, let's do a little reducing. So x to the first minus 1/2 would be x to the 1/2, and then y cubed to the 2/3. And then we have to distribute the 2/3 to both exponents, right? So we get x to the 2/6 or 1/3, and then y to the 6/3 or squared. Okay. And if you want, we could also write this as, right, the cube root of x times y squared. So there's also example 1a and b for you guys to try. And you'll have the solutions at the end of this video to check them. So do try them and then check your solutions at the end of the video. So example 2, it says, how can you extend the properties of exponents to derive the properties of radicals? These are the steps, okay? So we need to rewrite the radical as a rational exponent, right? So change this to AB to the 1/n. Then rewrite using power of product property. This looks like A to the 1/n times B to the 1/n, right? And then we're going to rewrite it as radicals. So it'd be the nth root of A times the nth root of B. Now that's kind of just like a formal definition. So let's look out to do it with numbers and variables in it. Okay, so B says, how can you rewrite this? So what we want to do is we want to reduce this down, right? So what we want to do is we want to figure out what things in 16 and x to the 5th, right, can we take the cube root of, okay? So if we look at 16, right, we want to find out if there's a number that can go into 16 that we can take the cube root of. Well, you should know that you can take the cube root of 8. It is 2, right? So that means we need to break down 16 with 8 and 2. Right. Then the next thing we want to do is break down x to the 5th, right? What can we take the cube root of? Well, x to the 3rd, and then x to the 3rd times x squared gives us back this x to the 5th. So we're going to break it down with these pieces and these pieces. Okay, so let's rewrite this as two different radicals. So the cube root of 8 x cubed times the cube root of 2x squared. Let me erase that. Right, what I'm doing is I'm just separating this piece because I know I can take the cube root of 8 and x cubed. This right here, I can't do anything with, so I'm going to leave that over. Right, so if we take the cube root of 8, it is going to be 2, and the cube root, right, so 8 becomes 2. Cube root of x cubed is just x, so we get 2x times the cube root of 2x squared, because that's what's left over after we got rid of this piece right here. So this would be our answer. And again, we have question 2, A and B. If if you'd like to try those too. And once you've tried them, at the end of this video, I'm going to have pictures of the solutions for any problems I tell you to try. So that will be towards the end of this video. Now let's look at some problems where we use the product property of radicals and the quotient property. So A, it says, what is the reduced radical form of this? Right, it's a multiplication problem. So right, what we want to do is combine them. So the fifth root, multiply our 16 and 8, we get 128. Now we need to break down 128 into a fifth root. Well, what does that break down to? Well, 32 we can take the fifth root of, okay? And then 32 times 4 gives us our 128. So we're going to rewrite this as fifth root of 32, because I can take the fifth root of it, times the fifth root of 4, which is just what's left over. Okay, the fifth root of 32 is 2, and then we have the fifth root of 4 left over. So our reduced form for this would be 2 fifth root of 4. Then this one, right, let's try one more. Okay, so we can do this one by rewriting it as rational exponents if you want. Okay, so we can try that. So we can change this piece and this piece. Right, we know this will be 8x to the 1/6 times 2x to the 1/3, because we're taking the sixth root here and the cube root here, our third root. All right, and then what we want to do is we're going to have to multiply them. And when we multiply, right, we want to find common denominators for our exponents. So I'm going to change this to 8x to the 1/6 times 2x to the 2/6. I just changed 1/3 to 2/6 so that they have common denominators. Now what we want to do is we want to factor out that 1/6. Okay, so we have 8x. If we factor out this 1/6, and then if we factor out a 1/6 from this 2/6, right, what is left over is 2x squared, right? Because this is a 2 up here, not just a 1. Right? So if you take out 1/6 from 2/6, you're left with 2. Now we can take the sixth root of all of this, right? So the sixth root of 8x times 4x squared, right, which is the sixth root of 32x cubed. Now this next problem deals with something called rationalizing the denominator. What we want to do is we need to get any radicals or anything like that away from our denominator. We can't have them in our denominator. Okay, so we're going to do this thing called rationalizing them. Okay, so what we want to do is first rewrite this as a radical over a radical. So the cube root of 2n over the cube root of 9m. All right. Now, how can we get rid of this cube root right here? Right, that's what we want to get rid of. That's our objective right now. Well, to do that, we need to find out what we need to multiply 9m by to get a term down here that we can take the cube root of. Okay, so right, we can't take the cube root of 9. What is something we can multiply 9 by to get a number we can take the cube root of? Well, we can take the cube root of 27, right? Cube root of 27 is 3. So we need to multiply this 9 by something to get 27. Well, that is 3. So we'll start off with the 3 here. Now, what do we need to multiply m by to get m cubed because we want to be able to take the cube root of it? Well, m times m squared. Right? So that means, I'm going to put this over here. If we multiply 9m times 3m squared, we get 27m cubed. Right? We could take the cube root of this whole piece, and it will bring us back to 9m. So we were looking for this piece, what we can multiply this 9m by to get rid of this cube root in our denominator. Okay, so the thing is, though, to multiply it to our denominator, we need to also multiply it to our numerator. Right? And it also has to have that cube root. So to rationalize the denominator, meaning get rid of any radical or anything like that, is we need to multiply the numerator and denominator by the same thing. Okay, so when we multiply our denominators, right, what happens? Well, we did it down here. It canceled out to 9m, right? And we got rid of that cube root. Now we need to multiply the 2m and 3m squared, right? So we have a cube root of 2 times 3 is 6, m squared n. Okay, and you could have wrote it as n times m squared. Okay? But that is our solution. Okay, I know that's a little difficult, so we'll do more practice on rationalizing the denominator. It's not the most important part of this, but it is something that we will need to do. So the next part of this section is multiplying radical expressions. So we're going to find the reduced radical form of each product. Okay, so a isn't written down, but I'm going to give you it. So we're going to find the cube root of 7 times the difference of 2 minus the cube root of 49. So that's our example. All right, so what you need to do is distribute to both terms. So we get 2 times the cube root of 7, right, minus the cube root of 49 times 7. All right, so we get 2 the cube root of 7 minus the cube root of 343. And then you can actually take the cube root of 343 and you're going to get 7. All right, the cube root of 343. All right, so that's distributing. The next one, we have two binomials, so we need to distribute to here and here, and here and here. Okay, so we get 4x squared, and then 2x times negative square root of 3 would be minus 2x square root of 3. And then we get another minus 2x square root of 3 from negative square root of 3 times 2x. And then lastly, we get plus square root of 9, all right, from negative square root of 3 times negative square root of 3. Now let's just reduce this up a little bit. So we get 4x squared minus 4x square root of 3, and then plus 3. All right. Now the last one is, again, rationalizing denominators. So this one deals with binomials in our denominator when we rationalize them. So it's going to be an extension of what we did earlier. What we need to do is get rid of this square root of 5 in here. Okay. Now, when you have a binomial, what we need to multiply the numerator and denominator by is its conjugate to get rid of that square root of 5 down there. Okay, what is the conjugate? Well, the conjugate is the opposite of what you see. Okay, so if this is 2 plus square root of 5, the conjugate would be 2 minus square root of 5. Okay, so this is a conjugate. Okay, another example of a conjugate, right? Say if we had like x plus 7, conjugate would be x minus 7. Okay. All right, so let's try and do this one. So we have 1 over 2 plus square root of 5. We're going to multiply the numerator and denominator by this conjugate right here. Okay, so 2 minus square root of 5 over 2 minus square root of 5. The reason we multiply the numerator and denominator by it, because technically we're just multiplying by 1, because if we reduce this fraction, it'd be 1. Okay, all right, so let's now multiply. So the numerator becomes 2 minus square root of 5. We need to multiply this times this. So we get 2 times 2 is 4. Then we get 2 times negative square root of 5 is negative 2 square root of 5. Then square root of 5 times 2 is positive 2 square root of 5. And then square root of 5 times negative square root of 5 is negative square root of 25. Okay. Now you'll see the reason we multiply by the conjugate is because these middle terms are going to cancel out. They're the opposites. So we get 2 minus square root of 5 over 4. And then this square root of 25 reduces to negative 5. Right? And then the last step is just 2 minus square root of 5 over negative 1. Right? And then we can just reduce this as negative 2 minus square root of 5. All right, because this negative 1 I just put in front of. And then there's a question 6, A and B, that I'd like you to try. And again, the answers for any of the examples that I had you try are going to be right after this example. So if you want to pause it now and try those examples before I show you the solutions, I do that. Okay, so here's the solutions to 1A and B. So there's also the steps. So if you want to pause it, you can. I'm going to move on to the next one. This is 2A and B. Again, pause it if you want to write down my work or check your work. Excuse some of my writing. And we're going to go to the next one. Here is 5A and B after some multiplication. And then the next one here is 6A and B. I will try and add some other practice videos from YouTube to help you with this, especially when you're doing problems on your own. So, but definitely let me know on Remind or Classroom if you have any questions on these notes.